A pothole is a type of failure in an asphalt pavement, caused by the presence of water in the underlying soil structure and the presence of traffic passing over the affected area. Introduction of water to the underlying soil structure first weakens the supporting soil. Traffic then fatigues and breaks the poorly supported asphalt surface in the affected area. Continued traffic action ejects both asphalt and the underlying soil material to create a hole in the pavement. Formation. According to a U.S. Army Corps of Engineers publication, Pothole Primer a Public Administrator's Guide to Understanding and Managing the Pothole Problem. Pothole formation requires two factors to be present at the same time, water and traffic. Water weakens the soil beneath the pavement. Traffic applies the loads that stress the pavement past the breaking point. Potholes form progressively, first from fatigue of the road surface, which can lead to a precursor failure pattern known as crocodile cracking. Finally, chunks of pavement between the fatigue cracks gradually work loose, and may eventually be plucked or forced out of the surface by continued wheel loads to create a pothole. In areas subject to freezing and thawing, frost heaving can damage a pavement and create openings for water to enter. Spring thaw of pavements accelerates this process when thawing of upper portions of the soil structure in a pavement cannot drain past still frozen lower layers, thus saturating the supporting soil and weakening it. Potholes can grow to several feet in width, though they usually only develop to depths of a few inches. If they become large enough, damage to tires, wheels, and vehicle suspensions is liable to occur. Serious road accidents can occur as a direct result, especially on those roads where vehicle speeds are greater. According to Eaton, al., potholes may result from four main causes. 1. Insufficient pavement thickness to support traffic during freeze-thaw periods without localized failures. 2. Insufficient drainage. 3. Failures at utility trenches and castings. 4. Miscellaneous pavement defects and cracks left unmaintained and unsealed so as to admit moisture and compromise the structural integrity of the pavement. Prevention. Eaton, al. Cite the following steps to avoid pothole formation in existing pavements. 1. Surveying of pavements for risk factors. 2. Providing adequate drainage structures. 3. Preventative maintenance. 4. Utility cut management. Survey of pavements. At-risk pavement are more often local roads with lower structural standards and more complicating factors, like underground utilities, than major arteries. Pavement condition monitoring can lead to timely preventative action. Surveys address pavement distresses, which both diminishes the strength of the asphalt layer and admits water into the pavement, and effective drainage of water from within and around the pavement structure. Drainage. Drainage structures, including ditching and storm sewers, are essential for removing water from pavements. Avoiding other risk factors with good construction includes well-draining base and sub-base soils that avoid frost action and promote drying of the soil structure. Adequate crowns promote drainage to the sides. Good crack control prevents water penetration into the pavement soil structure. Preventative maintenance. Preventative maintenance adds maintaining pavement structural integrity with thickness and continuity to the mix of preventing water penetration and promoting water migration away from the roadway. Utility cut management. Eaton, al. Advocate a permitting process for utility cuts with specifications that avoid loss of structural continuity of pavements and floors or failures that allow water penetration. Repair. Pothole patching methods fall into two distinct categories, temporary and semi-permanent. Temporary patching is reserved for weather conditions that are not favorable to a more permanent solution and usually uses a cold mix asphalt patching compound placed in an expedient manner to temporarily restore pavement smoothness. Semi-permanent patching uses more care in reconstructing the perimeter of the failed area to blend with the surrounding pavement and usually employs a hot mix asphalt fill above replacement of appropriate base materials. The Federal Highway Administration Materials and Procedures for Repair of Potholes in Asphalt Surfaced Pavements. A Euro Manual of Practice offers a comprehensive overview of best practices. It cites several repair techniques: throw and roll, semi-permanent, spray injection, and edge seal, which are explained below. The FHWA suggests the best patching techniques at times other than winter are spray injection, or by the throw and roll, semi-permanent, or edge seal procedures. In winter, the throw and roll technique may be the only available option. The guidance from the Council for Scientific and Industrial Research in South Africa offers similar methods for the repair of potholes. Materials asphaltic patch materials consist of a binder and aggregate that come in two broad categories, hot mix and cold mix. Hot mixes are used by some agencies, they are produced at local asphalt plants. The FHWA manual cites three types of cold mixes, those which are produced by a local asphalt plant, either one, using the available aggregate and binder, or two, according to specifications set by the agency that will use the mix. The third type is a proprietary cold mix, which is manufactured to an advertised standard. Throw and roll repair. The FHWA manual cites the throw and roll method as the most basic method, best used as a temporary repair under conditions when it is difficult to control the placement of material, such as winter time. It consists of 1. Placing the hot or cold patch material into a pothole. 2. Compacting the patch with a vehicle, such as a truck. 3. Achieving a crown on the compacted patch of between 3 and 6 mm. This method is widely used due to its simplicity and speed, especially as an expedient method when the material is placed under unfavorable conditions of water or temperature. It can also be employed at times when the pothole is dry and clean with more lasting results. Eaton, al. noted that the failure rate of expedient repairs is high and that they can cost as much as 5 times the cost of properly done repairs. They advocate this type of repair only when weather conditions prevent proper techniques. Semi-permanent repair. The FHWA manual cites the semi-permanent repair method as one of the best for repairing potholes, short of full-depth roadway replacement. It consists of 1. Removing water and debris from the pothole. 2. Making clean cuts along the sides of prospective patch area to assure that vertical sides of the repair are in sound pavement. 3. Placing the hot or cold patch mix material. 4. Compacting the patch with a device that is smaller than the patch area, for example vibratory rollers or a vibratory plate. While this repair procedure provides durable results, it requires more labor and is more equipment intensive than the throw and roll or the spray injection procedure. Spray injection repair. The FHWA manual cites the spray injection procedure as an efficient alternative to semi-permanent repair. It requires specialized equipment, however. It consists of 1. Blowing water and debris from the pothole. 2. Spraying a tack coat of binder on the sides and bottom of the pothole. 3. Blowing asphalt and aggregate into the pothole. 4. Covering the patched area with a layer of aggregate. This procedure requires no compaction after the cover aggregate has been placed. Edge seal repair. The FHWA manual cites the edge seal method as an alternative to the above techniques. It consists of 1. Following the throw and roll steps. 2. After the repaired section has dried, placing a ribbon of asphaltic tack material on top of the patch edge, overlapping the pavement and the patch. 3. Placing sand on the tack material to prevent tracking by vehicle tires. In this procedure, waiting for any water to dry may require a second visit in order to place the tack coat. The tack material prevents water from getting through the edge of the patch and helps bond the patch to the surrounding pavement. Efficacy of repair methods. An FHWA-sponsored study determined that the throw and roll technique proved as effective as the semi-permanent procedure when the two procedures were compared directly, using similar materials. It also found the throw and roll procedure to be generally more cost-effective when using quality materials. It further found that spray injection repairs were as effective as control patches, depending on the expertise of the equipment operator. Reporting. Some jurisdictions offer websites or mobile apps for pothole reporting. These allow citizens to report potholes and other road hazards, optionally including a photograph and GPS coordinates. It is estimated there are 55 million potholes in the United States. The self-proclaimed pothole capital, Edmonton, Canada reportedly spends $4.8 million on 450,000 potholes annually, as of 2015. Pothole art: artists have reacted to potholes by fixing them directly while at the same time creating art or by drawing public attention to the problem so as to force the concerned civic authorities to fix potholes. Activists in Russia have used painted caricatures of local officials with their mouths as potholes, to show their anger about the poor state of the roads. However, authorities in Manchester have taken a dim view of such activism that uses obscene images. See also, asphalt concrete, road surface. References. External links: Federal Highway Administration Manual of Practice for Pothole Repair.